Hello. Yeah. So I will be attempting the sleeping Barber concurrency problem. So here is the problem. To be honest, like I haven't seen the solution. I'm not sure like how this my first attempt of tackling this problem. Let's say yeah, the question says like we have n customers, and these n customers like will be coming to the barber's shop. So the barber is a single thread which will be servicing the client one at a time. So if there is no client that needs to be served, in such a case that the barber will be sleeping. That's what it is mentioned in the question. And if the barber is sleeping, then the customer will wake up the barber. And if since okay, let's say what are the observations that we made in the question. Observations. See here we are given that there will be n slots. Let's say yeah, there will be n chairs. We can think it as n. So at any point of time, n threads, n customer threads. So if customer waits for barber, if there is any chair left, otherwise the customer leaves immediately. If there is any chair available, then the customer occupies it. And so what I was thinking is like, since there are n customer threads, if we take the shop as a resource, then n. So and what I could think is like there exists, so we can keep track of this n as synchronizing primitives that comes to mind is like semaphore. So we can initialize semaphore with value n. So at any point of time, but the thing is here, if there is any chair left, okay, but otherwise the chair customer leaves immediately. Do we really can keep track of semaphore? Because semaphore if semaphore we will be executing the wait. So if there is no enough value for this n, if this n is 0, I mean if there are already n customers occupying the seat, then the new thread will be in waiting state, which is not what we want, because the customer leaves immediately. Okay, so what are the synchronous primitives that we have? Let me think about it. 2 minutes. Semaphore. Okay, instead of waiting, okay, locking mechanism. So we have semaphores, locks. So there are total customers that can be in a shop. Uh, let's say if three of them are in waiting room and one of them will be in chair, right? The customer counts. So let's say let's write so the APIs for us for this problem. So okay, we have some class representing this barber shop, and the actions that we have is like run barber and take haircut, called by the customer thread, called by the barber thread. So when customer walks in, and the other one is like white barber. We have n slots, right? So you can keep the track of the count, like seats. You can keep the test seats, and at any point these are total number of seats, and we can say occupied waiting customers that needs to be fulfilled by the barber, right? APIs. So let's think about the customer thread. So if it enters the shop, and we need to update this variable, right? So number of waiting customers, this needs to be updated atomically, and if the customer is a thread, right? So when it comes, then you must log this variable, right? So you must log this value, and I check what is the value of this, because if we don't log this value, suppose if this waiting customer value is suppose say 2, because 2 is the maximum amount, because one will be one customer will be served by the barber. So we need to check seats minus 1 value. If it is seats minus 1, then we can say that there is no place for the new customer to get cutting in the barber shop. So at that if suppose say if we don't log this value, suppose at this point of time, if new customer comes in and also checks the value, and if let's say if the value is seat value is 1, right? So what will they do? The second thread also will updates. So the updating is not atomic, right? So it may be interleaving at the, so what we can do is we can perform a logging on this waiting customers. Okay, so we need to have a lock, right? So let's say we need to lock. We're taking the reentrant lock and include this interface. So when the customer comes in, you need to check whether he can be able to get this service done by the barber shop. So we need to take the lock, because we need to atomically check the state. We need to this because to protect this variable, right? So that no other thread updates this value while we are checking this variable. So if waiting customers equal to so which equals to we can say this as, since it is a constant, barber shop dot seeds. Okay, we can access this via seeds. This, so what we can say is standard.println there is all seats are occupied, right? So the request cannot be served. Working out. So just before returning, what we need to do is we need to unlock this, right? And if the customer says that he can have this request, he can. If we reach here, it means that there is enough number of seats. So unlock. There are enough number of seats that can be served by the barber. So what as per the problem, the thing it is required is a customer waits for the barber, and it is mentioned like if the chair is available, okay. If the barber is sleeping, then the customer wakes up the barber. So the customer see there is another observation. Second observation is customer can signal barber, right? It means that we cannot use mutex. Mutex is exclusively for share protecting the data. So the signaling mechanism can be supported by semaphore. So we will be using semaphore to perform this action. Yeah, one more thing we need to keep track is waiting customers. But I forgot to update. Sorry. And the algorithm is here. Check if barber is sleeping. If so, send a wake up signal. So let's say this is a thread. This suppose say barber. The barber will be continuously executing this function. Run barber. You can say this. Yes, run barber. Run forever. Okay. Haircut is called by the customer thread. So we need to signal right. So initially at the initial state would be the barber will be sleeping, right? So this block of code will be run by the function will be run by the barber thread. The thing that we need to take care is like we need to represent the initial signal as a semaphore. Okay. So initially the barber would be running, right? So there will be a signaling mechanism. So let's say we have semaphore waiting for, we can name it as waiting for customer to enter. We can name it as waiting for customer to enter. This is okay. It is causing. Yeah, I think we need to pass the count, right? So there will be exactly one. Do we really need to pass? I think we need to pass it. Yes, one. I'm not entirely sure on that. So waiting for customer. So this barber thread would be initially waiting for customer to enter. Would be so we need to, I think we need to wait here because the customer needs to signal, right? So initially it will be in sleeping state. And we need to pass signal acquire. So what? Let me check what exactly is the behavior of the semaphore. Like I'm not entirely sure on this wait and signal part. Wait and signal in Java. Let me check. Give me 2 minutes. I can be back. I need to get this information regarding the wait and signal. So another thing is any thread can signal the barber, right? Where what exactly is semaphore Java? Okay, let's leave that part and somehow interest create a signal and suppose if the other thing here is like only one customer, see this part will be handling the slot availability, and the other thing that we do have is like customer walks in, right? So only one customer can be served by the barber at any point of time, so needs to wait for the barber signal on completing the haircut, because once this part ensures that the threads coming till this point, I mean till here, like how many threads we have? Okay, seeds, let's say n threads will be reaching here, and they need to wait until barber signal on completing their haircut. So how will be doing that? For this we are saying this is for waking up, and we also need a mechanism to solve this issue. What will happen if semaphore, let's see, Java semaphore permits? What if we have no permits? Semaphore, okay. So what I was thinking is because a thread needs to complete its execution, right? So only when the barber finishes the execution, this thread can go out of the barber shop, uh, and this function completes the execution, right? So we need a mechanism from barber to uh, this this customer walk-in function. What I was thinking is like, do we really, like, is there any mechanism to signal the customer? What if we have n semaphores to simulate that? Suppose if we have n semaphores, like every semaphore will be waiting, so we can have a guarantee that there will be exactly n like maximum number of customers can be reached till here. So if we have n semaphores, we can call signal operation. Let's say, let me get a clarity on the semaphore operations. Like I always get confused between the way acquire and the release. It also has this counting semaphore. Okay, let's say on acquire part, make some pyramids. Okay, let's say on acquire we have semaphore in Java. Let me go through geeks for geeks. Semaphore, constructor for semaphore takes two parameters. Number specifies the initial permit count. Thus it specifies the number of threads that can access the shared resource at any one time. If it is 1, then only one thread can access the resource at any time. By default, all waiting threads are dead. Passing 0 to semaphore constructor, what will it happen? Passing 0 to semaphore constructor. So the argument of semaphore is the number of permits that are available. It can be any integer, not just 0. For sim 0, all acquire will block, and try acquire calls will return false until you do release. Initial number of permits available. The value may be negative. Okay. Is this by function Barber? Yeah. So if initial number of permits is 0, it means the customer thread will not start first, because or the barber needs to the barber thread will be calling is waiting for, will try to acquire sleeping state, because you try to acquire this semaphore, because initially it is 0 and it will be blocked on this semaphore at the barber thread, and once a new customer comes in, it will cause the release. So what happens if we call release on semaphore multiple times? So what this operation does is acquire basically try to get the lock by decrementing. If it's 0, then it will be lock. So here we are signifying that initially there are 0 number of customers. Right, and the release will the release part, let's see what exactly this does. Okay, signal 0 permit. Semaphore release operation, I think it will increase the semaphore release. Each release has a permit potentially releasing the blocking acquirer. Semaphore release the permit. That's the number of current available permits. Okay, available permits. So release will obviously increase the permit count. Here the permit count signifies is nothing but a number of customers. Here the permit count is nothing but a number of customers, so it will increase the customer count. Obviously when you are trying to acquire more than one, this will be there will be no blocking at this point of time. And the other thing that we need to take care is, once the request is served, at this waiting customers, let's assume that the barber is serving the request. I mean, is trying to giving a haircut. Barber is giving haircut, right? So and one more thing that we need to take care is, like when releasing this barber is giving haircut, and once this value leaves, we also need to update and we need to take a lock, right? So this lock will be only held by the customer. And this operation is atomic, right? So this can be done initialization and lock dot unlock. And we also need to because this request is served, and we only come to here only when the barber completes the haircut. So needs to signal the customer on completing the haircut. So what we can do is, let's say, if three if three threads comes till this point, and they all needs to wait, right? So they all needs to wait. So we need a mechanism to simulate this behavior. So what we can do is we can have some other semaphore. So we can have another semaphore waiting for Barber to cut the hair. And this will be called by let's say what is that, this needs to be called by either Barber can perform this because on signaling the Barber, on releasing it will increase the permit, so the Barber will be first will be unlocked at this point, and he will try to give the haircut. And so if there is a so if CPU, if the other CPU, okay, and let's say we have initial permits as 0, and here wait for Barber to complete. So if you try to acquire, because initial permit is 0, if you try to acquire, initially there will be no threads, right? Okay, part and threads will be reaching here and need to acquire. Suppose if and threads simultaneously executing this acquire, and all of them will be blocked, right? So there will be no, it will be initially 0, so there will be no point in because it is 0, and they all will be blocked right here, because the Barber needs to finish the haircut. So, and what we can do is once if he got signal from here, he will be jumping. This thread will be unlocked because this is only thread running continuously, and we can simulate thread dot sleep, let's say 1 second to complete the request. And what we can do is waiting for Barber to cut the hair, and so release. So once Barber releases the permit, it means that increase the permit count, which translates to haircut is done. So we can also keep track of So we can say system.out.println waiting for Barber. Yep, this okay. We can say we can also keep track of another variable. Say haircuts done. Haircuts done. We can say system.out. Completed haircuts, right? So which will not, suppose initially it will be 0, right? So this will signal this and it will trigger this, and all other threads will be waiting here. If there are 3, then -1, -2, -3, -3, all the 3 threads waiting here will be -3. And the thing I was concerned is there will be release will be increasing the number of customers, and the query will also try to decrease the count, and it will release. Suppose if this value becomes 1 and this, suppose the thread switching here, the value will be -n. Suppose the thread after executing this statement, there is a context switch and it goes to here and it executes this because it is sleeping, and it comes back to here, and there are 3 other threads switching here, and this value will becomes -3 because there will be at most 10 customers, right? So -3, and all the threads will reach here only when acquired is positive value. So I don't think we will get in the positive value until unless all the threads are completed, and even though all the threads are done, after exiting only they will be going out. Okay, the Barbers. Okay, I think this solution works fine because at the end, like and they're trying to acquire, then all the customers will be leaving at once, and even though if there is a free slot, we don't we are not filling that request because this is being acquired, right? Okay, let's try to simulate this and see what are the improvements that we can do. uh, so what are the problems with this solution is like the cost uh, what are expectations. My expectations would be uh, so once all the customers will be leaving at a time, so this needs to be solved because with this configuration, if all the seats are filled and if one customer completes a haircut and if he goes out, then the other threads will not be, I mean, actually they should be, if another request comes in from a different customer, then the request should be fulfilled, the customer will process it, but that will not happen with this code. Let me go to the driver code. Let's say we have thread Barber, thread new thread new runnable. Let's say that we have this is okay. We first of all we need to create the Barber shop instance. Barber shop dot okay, we need to, this is this set will be executing this function, catch the exception, and let's say we have exactly one we can create a loop, right? Let's say list of thread applets. We'll create list of thread applets and we'll be executing them one by one. Thread list. I less than, let's say 5, and we will be adding this add new thread new runnable, and all will be executing Barber shop. Wait for so what is the IP that we have? Customer walks in. So every thread, these threads will be and we need to start the Barber thread. Start the Barber thread. Barber. What is the name that gave? Okay. Barber thread dot start, and for thread object thread list we say start, right? And we will be joining all the threads one by one at the end. So let's take a try, test our solution. Okay, see, not this one, not the pattern problem. All seats are occupied, walking out. Oh, that's strange. Okay, initially Barber thread would be waiting on this because initially 0 it will be blocked. Restarting this. So what is the initial waiting customer? So waiting for Barber to cut the hair. All barbers occupied were going out. Okay, let's see. Let's pass an identifier to this thread. And I token. So okay, that's this. Starting one by one. The 4 and 5 are being left out. Barber is giving haircut, completed one. Barber is giving haircut, completed one. Completed. completed 3. अच्छा okay, the barber thread will be running continuously, right? And I don't think it has any mechanism. So let's suppose say if okay, it also let's say system.out printer and leaving token number is leaving, right? So let's do that. So initially the 4-5 goes down, Barber's getting here but completed 1, leaving 1. What is this output tool? Completed 1, leaving 1, Barber giving haircut. Completed 2, leaving 2. So n threads will be reaching here, needs to wait for Barber signal on completing the haircut. So let's say if we have, let's say 20 threads, so if this another thread comes in here at this point, then the thread goes so if I think this solution works fine. But what I was thinking is not sure, because if here everyone is leaving, but uh, see, uh, leaving one barber is giving haircut, computer two. So barber is giving haircut completed one, and all seats are occupied, right? See, if you could see, uh, when fourth person comes in, and if there is already one has already done, let's say there is a statement, yeah, completed. Completed. Where is the statement? Yeah, haircuts done. Uh, we can say that suppose so for first person let's assume that comes in, acquires this log, says releases the permit, so which will eventually comes here, and this will increase, so the barber starts giving haircut and haircuts done, and at this point of time there are multiple threads coming here at the end. Let's say what would be the value. Standard out dot println take for barber to cut hair dot available permits. So we are trying to acquire the permits, right? Let's see. It will never go below 0 on acquiring. So some implementations will go to the negative value, and some implementations will block on 0. So if it is 0, then there will be no it doesn't go to the negative value. I think Java has this implementation, I guess, because on acquiring will increase the permits. Let's see. Release the waiting for barber to cut the hair. So initially I'm assuming that it will become 0, so that's not the case. So it will obviously will become acquire permit, right? So acquire permit, and this will need to wait for the barber to signal. So what operation we are doing is acquire will decrease the permit count. So it means if it is 1, then only the acquire can be done by a thread, and it will go outright. So for the thread, in that case, see, barber giving haircut complete 1, barber giving haircut complete 2, giving haircut complete 3, all seats are occupied. See, everyone has completed their execution. Barber gave three uh, three three uh, three cuttings and three haircuts, but still there it is. Let's print the require payments count. See, Barber is giving haircut, and there will be three threads. Will be reaching till this point, right? Three threads will be releasing the permits. So let's see. Control and permits for Barber. Yeah, see, permits for Barber. Okay, yeah. So Barber is giving the haircut. For the first thread, the Barber is giving the haircut, and the permits for Barber will be one, right? And completed one. And Barber is giving haircut. Completed 2, Barber is giving haircut. Completed 3. See, all seats are occupied. Okay. Completed 1, and we haven't come to this place. Permits count. So permits for Barber. Okay. The permits count will go. What we are doing is we are releasing the permit, waiting for Barber to cut the hair. In the next iteration, we have this more. We have all of this, right? So permits, 2 permits, and obviously we'll acquire, and one thread will acquire will obviously we'll be releasing the permit. So on releasing the permit, we are trying to acquire the token here. So permit count 2. So the 2 permit count leaving. Okay, leaving 1. So access to 3. All seats are occupied, walking out. Wow. It's directly going to 17. Access to 3, all seats are occupied. Access to 1, 2, Barber is giving haircut. All seats are occupied. Completed 1. One completed 1. Barber is giving haircut. Completed 2. Barber is giving hair. Completed 3. All seats are occupied. Again, access to 8. Okay, that's it, guys. This is my solution, and it was took a long time, but there may be some other solutions. Like I will try to get some official solution here. And thanks for watching. Bye.